Okay, so now we're actually going to start on the content. Now that I gave you a little bit of information on how the course is set up and hopefully answer some of the questions that you've been sending me, now we're going to start talking about trigonometry. Now, before I start with the notes that I have here, I actually want to mention some interesting things about trigonometry. So most people, if they think about trigonometry, there's a couple things that might come into their mind. You could think about circles, right? Or you could think about triangles, or you could think about angles, right? And all that is part of trigonometry. That's very true. And we're going to start, for example, in today's lecture, we're going to start talking about angles. So you can easily see how trigonometry has a lot of applications. Anytime that you have to build something, you have to work with angles. So you can easily see how this is applied to physics, how this is applied to engineering, to architecture, etc. Anytime you have to build something and you have to measure, those angles, you're going to be working with trigonometry and a lot of the identities and properties that we're going to see in this class. However, surprisingly, the higher you go into your education, so once you're taking the higher level, whether it's physics or engineering classes, you're going to see that trigonometry shows up again in a sort of less geometric setting. It's still geometric in a way that you're going to learn once you study, calculus and linear algebra. But it still arises in very interesting ways. We're going to be defining later in the course trigonometric functions. So basically functions that measure ratios of sides of triangles. And those functions actually arise when we're trying to approximate other types of functions. And it's a very amazing thing how those functions show up. That's called Fourier analysis and representing functions in terms of Fourier series. So it's a little bit advanced because we can't really talk about infinite series. We don't have the materials for that. However, once we define those trigonometric functions, I will talk a little bit about how to approximate functions with basically a sums of trigonometric and a trigonometric function expression. So it's very interesting how trigonometry arises in settings where you won't expect it. They also arise a lot in calculus when you're trying to simplify expressions. A lot of the properties we're going to see about these strict functions, they're going to allow you to simplify things in calculus. It'll allow you to simplify integrals, simplify formulas for derivatives, right? So just very useful stuff. And again, in those settings, even though it doesn't seem to be geometric, there's still geometry below or in the base of it. So we're going to talk about some of those things, not in detail, again, because it's a little bit more advanced, but I will mention it because I feel that trigonometry is an interesting subject in that sense, that a lot of the applications are kind of obvious, but then once you study more, you see how it arises in areas that you don't even imagine that trigonometry will arise. But we'll get to all of that. As I mentioned, that's more advanced, so we're going to start a little bit slower. Okay, we're going to start talking about angles, so more of the geometric interpretations of trigonometry. Now, if you're following the book, which you can access it through Alex, in the Getting to Know Alex video, they tell you how to access it. But this is chapter 5, section 1. So we're going to be starting here. You're free to look at the other, the previous chapters. It's basically algebra review. And we'll be skipping that for now. However, there is an assignment in Alex, which is an algebra review. And if you do that, that'll basically get you all the, let's say, algebra background, just reminding you how that works in terms of what you need to complete all of the work that we're going to be doing in this class. And I will remind you about some basic algebra things as we go as well. Okay. So what are angles? Before we start with that, we're going to start with a sort of very high school geometric approach to this. If you remember in high school geometry, if you took that class, you studied these objects called rays. Okay. So what is a ray? A ray, which we're going to be denoting by this symbol, PQ, and then a sort of horizontal arrow on top of it, is a portion of a line. And I'll show you how this looks like in a moment. So if the definition confuses you a little bit, you'll see it that in practice is very easy to understand. But a ray is a portion of a line consisting of an endpoint. Sometimes it's called starting point. We're just going to be calling endpoint in this class to match what Alex does. So consisting of an endpoint, which is the point P, a point Q on the line, and then all points in the direction from P to Q that lie on that line. So how does a ray look like? Okay. So we have two things, right? So we start with the endpoint P. Right? Now there's also another point Q. So let's put it around here. So what is the ray PQ? The ray PQ consists of all points on the line that starts on P and goes through Q, right, and continues indefinitely. So this is what PQ with the arrow on top denotes. So let me use a different color. Let's use green. All right, so this right here is the ray PQ. Now, one thing to note is that when you write something like this, where you have, oops, let me use a different color. When you write something like this, where you have the notation that we're going to use for rays, where you have the endpoint, another point on the line, and then the horizontal line on top. When you do that, just make sure that your endpoint is always the first point that you write in this symbol, right? So the whole symbol is, PQ and then the line above. Make sure that the endpoint is always the first one. Okay. So for example, given these points P and Q as they lie here right now, this ray here is different to the ray. So let me do sort of division here. This ray here is different to the ray QP, right? Because if you see this symbol QP or the ray QP, always read the first point here as the endpoint. Right? So in fact, what is this ray? This ray is the ray going in the opposite direction. So this is saying that we have, and let me try to draw it as similar as possible. So we had P here, and then Q to the right and a little bit above. This symbol here is telling you that the endpoint is now Q. So you start your line at Q, or your ray at Q. Right, so here, and then you go towards P and include all points in that direction indefinitely. Right? And that indefinitely behavior, we encompass that with using this arrow symbol here. Basically, that arrow means that this line goes on indefinitely. Okay? So that's basically the one thing that you have to be careful with using rays, that the order in which you write the points here does matter. The first point is always the end point. So it's not the same that the ray PQ is equal to the ray QP, right? That order matters. Okay? So that's what rays are, right? So a very simple interpretation and how to, in a very easy, geometric visualization. Now that we have rays, we can actually define what an angle is. So how do you get an angle? How do you form an angle? Well, you start with a ray, and in this drawing here, I started with the ray PQ that I drew in red. So you start with the ray, and then you rotate that ray, whether it's clockwise or counterclockwise, in the clockwise or counterclockwise direction, any amount you want, and I make that motion here as this arrow in orange. So here I'm rotating in the counterclockwise direction. So counterclockwise just means in the opposite direction in which a clock usually runs. So a clock runs, from 12 to 1 to 2, etc. Counterclockwise, think of running the opposite way. So 12 to 11 to 10, etc. Okay? So I start with the ray PQ. I rotate my ray a little bit, so by an angle of theta. And this symbol theta, I'll explain what it is. I basically rotate it, the distance showed by this orange arrow, and then I stop. And then I have this new ray, which I'm calling PR. Okay? So in that process, notice that now I created this sort of distance in between the rays PQ, the original ray, and the ray PR, which is the rotated version of my original ray. Right? So this here is called an angle. Right? Now, how do we denote angles? Right? So we're going to be denoting angles using Greek letters. Right? So let me introduce them. So notice that I denote this angle here in the picture that I drew with this symbol theta. Right? So that's a Greek letter theta, and it's very easy to draw. Basically, you kind of draw an O, and then you kind of do that wiggly part at the end. Okay. Now, we're going to need more than one variable to represent angles, so we're going to be using more than one Greek letter. Right? If we have another angle that we want it to be different than theta, we're going to be using the Greek letter alpha. Okay. So it's also very easy to draw, right? So kind of like that. We're also going to be using the Greek letter beta, which kind of looks like a capital letter B in our usual alphabet, but you kind of have this extra portion of the line, right? So you can draw it like this: do a longer line and then do the B above, right? And then finally, we have the Greek letter phi, which is kind of like alpha, but rotated 90 degrees counterclockwise. Right? So you can draw it like this. So anytime I want to draw an angle, what I'm going to do is I'm going to start with the ray, rotate it by a certain amount, and then in the area that I left inside, that's what the angle is. And I'm usually going to write, I'm not always going to write this orange arrow that I drew to kind of model the motion that I did, but I will always write this angle close to where the closest to the point P, the end point, and that's going to be the angle. Now, there's a couple things when we do a construction like this for an angle. This point P that you get, it's originally the end point when we just start with the ray PQ. But now that we have two rays with the same end point, we call this point P the vertex of the angle. Right? So we start with the ray PQ, rotated, in this case counterclockwise, a certain amount, and with the ray PR. Right? And then the point there that those rays have in common is called the vertex of the corresponding angle theta. The initial ray PQ that I started with is called the initial side of the angle theta, and then PR is called the terminal side of the angle theta. So let me give you another example before I go to the next part. So I'm going to do it in this box area. So let's say that I start with a ray. So it has an endpoint here, and then Q is here. So we have the ray like this. This is the ray PQ. Now I want to create an angle by rotating now instead of counterclockwise in a clockwise direction. Right? So what I'm going to do is I'm going to rotate a certain amount this way, a certain distance. I'm going to stop there at the end of that arrow, and I'm going to draw the resulting ray. Right? If I do this, I end up with this ray here. Right, so now Q has shifted all the way to this new point R. Right, so this is the ray PR. Now that distance in between, or that's in that space, open space area, that's where I'm going to write my angle. So theta is the angle above. Let's say I want to use a different name. I'm going to call this alpha, for example. So this is the angle alpha. So again, it doesn't matter in which direction you rotate, right? You can rotate whether it's clockwise or counterclockwise. Either way, you get an angle. Now, in this case, notice that PQ is the initial side. It's the side that we started with. And then PR is the terminal side of the angle. And P is the vertex. So just a little bit of vocabulary. It shouldn't be too bad. It's kind of intuitive. Just if you always draw your angles like this, it's pretty obvious what's the terminal side, what's the initial side, and what's the vertex. Okay. Now that we know what an angle is, I want to kind of stop drawing them just freely in the white space. So what I'm going to do is that I'm going to embed angles in the XY plane. Okay. So if you remember, and I'll talk about this definition in a moment, but you've taken algebra in high school at least, and if you remember, in high school you talked about the XY plane. So what's the XY plane? You draw two horizontal, well, one vertical and one horizontal line that intersect at 90-degree angles. So I haven't introduced 90-degree angles in this class, but I think that you know what a 90-degree angle is. Just means that the two lines are perpendicular, right? And then we usually label the horizontal axis or the horizontal line, we label it with X, and we label the vertical axis or the vertical line with Y. Okay. So this is what the XY plane looks like. Now, the reason why working with an XY plane is useful, it's because it lets us kind of work with points, right? So if you remember, you can add points to this XY plane. So let's say we move 1 point, 2 points, 3 points, 4 points in this direction. 1 point, 2 points, 3 points, 4 points in this direction, right? And usually you just label the first jump so that we know that every point that you get or every dash is just one more unit, right? Now you can use this to label points on your XY plane because, for example, if I want to move 1 unit, so starting at the origin here, and the origin is always where the horizontal axis and the vertical axis meet, right? So this is the origin. And in terms of points, this is the ordered pair 0, 0, right? Meaning that the x-coordinate is 0 and the y-coordinate is 0. So let me make a note of that. And anytime you write ordered pairs, actually use a different color. Anytime you write ordered pairs like this, the first coordinate is always the x-coordinate, and the second coordinate is always the y-coordinate, so the one that lies in the y-axis or in the y direction. It doesn't have to lie in the y-axis, just in the y direction or vertical direction. Okay. So again, the origin is always the point 0, 0. Now let's say I want to find the point x equals 1, y equals 2. The way you do that, just as a reminder, is that x equals 1, so you move 1 unit to the right in the x direction. Y equals 2, you move 2 units up in the y direction. And this is the point x equals 1, y equals 2. Okay. Now let me do more dashes here. If I want to find, for example, the point -2, 0, right, that means that your x-coordinate is -2, so you move 2 units now to the left direction. Right? So the way you read graphs is that you read them as working positive from left to right. So anytime you move towards the right, that's positive direction in terms of the x-axis. Anytime you move up, that's positive direction in terms of the y-axis. Okay? And then conversely, if you move left in the x-axis, that's a negative step. And if you move down in the vertical axis, that's a negative step. Okay? So if I want to find the point -2, 1, that's 2 units in the negative x direction, so to the left of the origin. And then -2, 1, so then I move 1 unit up. And this is the point -2, 1. So let's do one more. Let's say I want to find the point 3, -1. So x equals 3, y equals -1. X is positive, so you move 3 units in the positive x direction, so that's towards the right. And now y is -1. Right? So that means you want to move in the y direction, but negative. And then remember that positive is always up in the y direction, so negative is down. So if I want to find y equals -1, I move down 1 unit, and this is the point. This is the point 3, -1. So that's just a quick reminder of how the XY plane works and how to find points in the XY plane. Okay. Now, the reason this is going to be useful for us is because it's going to allow us to embed our angles in this XY plane and talk about points in our angles with actual coordinates. Okay. So that's what definition 3 is going to be about. However, just to not make this video too long, I'm going to stop there and continue on the next video.